Hello, good evening, everyone. Am I audible? I hope I am audible to everybody. Welcome to the first webinar hosted by ICE platform. I will take you one of the slides from my end. Just give me a moment, please.
Madam, you'll have to put on Akhil's camera or he can on it himself.
Yes. Akhil has to switch on his camera, sir. Yes, please. Good evening, everyone. So this is the platform for everybody who can share the knowledge and be here for their technical knowledge and innovators and global leaders who can be part of this particular e-platform. So from on behalf of Tak Matthews and Priyanka Chaudhary and myself, I am welcoming everyone for this e-platform. Also, make sure that if anyone is there who wants to make a notes and can do the short video and take a thing, you can always do so. So I will introduce myself. I am Kshitija Poddar, working with IC as a general manager, and it is a kind pleasure to welcome you everybody. So let me begin to share a little information about IC, as everyone is obviously aware. However, I will still share. We are being IC India, fourth largest exhibition for the elevators and escalators, bringing in together all the manufacturers, technology providers, innovators, and global leaders under one platform. It is a proud achievement for all of us to reflect the trust and recognition IC has earned worldwide. But IC is just not an exhibition, right? It is a hub for networking, knowledge exchange, and driving industry growth. Through our presence in both India and Africa, IC has become the trusted platform that connects regional industries with global opportunities. As a part of this vision, we have created ICE platform, which is a unique initiative that allows our exhibitors to showcase their technical expertise, products, and company profiles to a much wider audience. The platform is designed to provide ongoing visibility, build credibility, and keep exhibitors connected and with stakeholders throughout the year. Share that these webinar sessions will be now held every Tuesday. Each session will feature insights from our exhibitors and industry experts, helping us all to learn, share, and grow together. To inaugurate this exciting e-platform journey, we are delighted to have with us Mr. Jothi Ramalingam and Mr. Akhil Chacko from Aadit Fire Testing Laboratory Private Limited. Let's get started and look forward to an insightful session together. Also, please note, today's session will conclude with question answer segment where questions may be submitted in writing through a Zoom chat, and our panelists will answer them at the end of the question and answer page. Jothi sir, Akhil sir, you can start with your presentation, please. Akhil, you can unmute yourself and please proceed with the e-webinar.
Declined to be promoted to a panelist.
Okay. Okay, there is some technical issue. We are just trying to sort it. Please be on hold, please. Sorry. One second. Hey, Akhil, as I can see you online, could you please share your screen?
Hello.
Yes, Akhil. Your camera is starting now.
Yeah.
I'm
So
unmuting myself. Yes.
And then I'll start with my presentation.
Yeah, sorry for the confusion. Can you hear me?
Yes, yes, Jothi sir, I can.
Okay. So good afternoon to all the members who have joined here. And first of all, thank you to Mr. Tag Matthew, Priyanka, and Shijida for having given us this great opportunity to share some of our thoughts about fire testing. And we'll have two sessions, I mean, two parts of this entire event. The first part, I'm a director in Aadit Fire Testing Laboratory Private Limited based in Chennai. I will just talk about a general introduction on testing, what is required about, and in testing, what are the essentials of testing. And that's a general one about any kind of fire testing. And then Akhil will take over from here and specifically talk about lift landing doors. So the topic today is that do fire tests save lives, right? So before we get into the actual topic of testing, I would like to just share some of the my ideas. Okay, we Indians, I mean, all over India people, we are all very God-fearing. And whenever we do something, we buy a car, we buy a bike, or we build a house, or we buy a plot of land, for anything good, we do a big puja. We spend a lot of money and do a havan and invite a priest and do all that, primarily to ask for God's protection, to help us, guide us, and protect us. Now, we literally take that for granted that once you do the Havan, God is responsible for our safety. We don't have to take any precautions. We can see people driving in one-way traffic without helmets, where there is a 60-kilometer speed limit, people are driving at 100 kilometers. Nobody cares about signals on the road. Jiska marzi, wherever you find space, you get in. And that attitude of casualness towards safety, you can see it on the road. You know, there are four people, family of five traveling on the same scooter, and you know that God is there to protect them. Otherwise, they will not be really reaching their home safely. So now coming to testing. Why do you test? Again, I would like to say, give a small analogy that there is a guy, a very senior officer in the government, let's say. He comes to me and says that my son is the best or the highest, he's got the highest IQ in the state of Tamil Nadu. Now, he needs to have some kind of a proof or some manner in which he
All
is it audible now?
Yes, sir.
Okay, sorry. So as I was saying that he comes and says that my son is the most smartest in the state of Tamil Nadu.
Apologies for the technical errors which we are facing. I think there is some internet connectivity issue which is faced there. So we are trying to get it as soon as possible again. Thank you. Okay, sorry for the apologies again. There is an internet connectivity issue at the Akhil's office, I believe. So they are trying to just reconnect once again. Kindly hold on, everyone. Thank you.
Yeah, sorry. Is this connected now?
Yes, connected, sir.
Sorry, thanks a lot. Okay, we are back. And so basically, when he says that my son is the smartest, we need to put him through a test. And suppose the father is in a position to influence the results of the test, then naturally you will find that son is the smartest in Tamil Nadu because he would have got 99.999 marks in the exam. This has happened many times in India, in Bihar and all that. So the test itself should be done by an agency which is above bias and follows a certain norm, some standard, some specification. So that applies to fire testing also. So as a testing laboratory, that laboratory's objective and responsibility is to give the client accurate data, not something in favor of him or against him, but do the test genuinely as per the specifications, as per the standard set in the specifications, and also ensure that you give him all the data in a very transparent manner so that he's able to, suppose he passes, it's very good. Suppose he's not able to qualify also, he needs to understand where the product failed. So he needs to get data, accurate data, so that he can make corrections, come back and do a retest and qualify. Because we are talking about fire safety where human lives are involved. No, it's not that when you test a product, even if it's a substandard product, you are able to pass it through, that can result in a loss of life sometime in the future. God forbid there is a fire accident, and this product, which is supposed to do certain act of preventing the fire from going from one side to the other side, does not work, and finally ends up with people dying. Then indirectly the responsibility of the particular life of somebody going or passing or somebody dying indirectly comes on to the people who manufactured, the people who inspected it, and the people who have tested it. So testing is not like any other business where you can take a very casual attitude and pass or fail. There has to be a very, very transparent process to do that entire mechanism. And along with it, we need to also ensure that we are qualified, our equipments are properly calibrated, and the entire process of testing is done without any compromise so that the end customer gets genuine results which will help him and the industry to which he is serving. So this is the basic requirements of a testing agency like ours. And accreditation does not mean that you are absolutely, licensed to do anything you want. Accreditation is just one of these processes in the way to just to certify somebody that he has certain equipments and he has a competence to do the test. But it's not a guarantee that he is going to do that test according to the standards, or he is going to do it in an impartial manner. So there are two different things. So keeping that in mind, we would like to go into this testing of landing doors, which is a very critical product in a building, wherein a lift landing door failing means it can allow the smoke to pass through the door and go through the lift shaft right to the upper floors without people even realizing that there is a fire in the ground floor. And it can result in, because 2 minutes of exposure to smoke means loss of life. So it's a very difficult and a very critical kind of a role that the lift landing door is playing. And we have actually taken a lot of effort, because the lift landing door, the test requires a lot of extra things to be measured and tested, unlike a very ordinary fire door. So we have we've taken a lot of extra effort to ensure that we comply with every little requirement that standard says, to ensure that our test is to the T, following everything that is required by the specification. With that introduction, I would like to hand over to Akhil, who will carry on from here on the specifics about this test. Thank you.
Hi, good afternoon, good morning, and good evening to everyone on all corners of Earth. So I'll just start my presentation. So hi, I'm here to give a brief introduction or a brief commentary on EN 8158 and IS 17518 Part 2 or ISO 3008 Part 2. So all are similar standards. So I'll be just talking about EN 8158 particularly in this presentation. So as we know, the landing doors are the barriers in order to prevent the fire to entering into the shaft area. So if there is a fire in the floor area, the door is supposed to prevent it, and the gases, hot gases or fumes are not supposed to enter into the shaft area of the lift. So for that, the test is being done, and the evaluation is based on integrity, insulation, and radiation. So if we see the difference between the normal door testing or the landing door itself, if it is been tested with BS 476 Part 20 or EN 1363 Part 1 general requirements or EN 81 and with EN 8151, EN 8158 is the major difference is that the measuring of integrity. So first, when we test the door with BS 476 Part 20, the gap gauges, 6 mm gap gauges or 25 mm gap gauges and cotton pad comes into play, where the integrity is measured based on those requirements. But in EN 8158, it is not, we are not measuring the integrity with gap gauges or cotton pad. Instead, it is a comparison of carbon dioxide leakage through the door into the canopy and the measuring system. So first, let me tell what is integrity. So here in this particular standard, the integrity is measured by sustained flaming happening for 10 seconds at any point of time is called a failure of integrity, and the leakage of carbon dioxide through the door opening. And it should not exceed 3 meter cube per minute or its width after 14 minutes of the start of the test. That will constitute an integrity failure. So then we are measuring the thermal insulation where the thermocouples, if it is an insulated landing door, then the thermocouples are placed on the unexposed side of the specimen. And if it measures 140 degrees Celsius on the surface of the specimen, or if the size of the specimen is greater than 300, then it will be 180 degrees Celsius or Kelvin. Or if it is between 100 and 300 mm panel width, then it will be 360 Kelvin or degrees Celsius. In that case, that once this reaches, that will be the insulation failure of that particular specimen. Then we have radiation. So at any point of time, the radiation is exceeding 15 kilowatt per meter square. Then that is the radiation failure for that particular specimen. So then we have the classification of this particular thing, that is, it is called E with respect to time. E stands for integrity, I for insulation, and W for radiation. If a specimen is passed for integrity 120 minutes, insulation 30 minutes, and radiation 60 minutes, it will be E120, E830, and EW60. Then if we see the testing procedure, we can split the testing procedure into 5 parts. That is, part number 1 is the pre-test arrangements for the test. Then pre-test flow verification before the test, instrumentation on the sample, then testing, then reporting. This will be the parts that we will be following for the landing door testing for fire resistance test as per EN 8158. So the first part is the construction of the construction of the supporting construction itself, and also the installation of the landing door to the supporting construction. Then the final setting of the sample, then the pre-test examination will be the part 1 of this particular test. And the lab is supposed to provide a frame where the landing door is being installed. So once the sample is installed to the surface of the supporting construction, and the frame will be fixed to the furnace, then we will be doing the test. So when we are selecting the supporting construction of this particular landing door, the standard says to select the supporting construction bricks ranging from 800 to 1600 kilograms per meter cube density of supporting construction. That can be aircon blocks or concrete blocks, but whatever follows within this range has to be chosen for the testing. And the thickness can vary from 200 plus or minus 50 mm. So once those are chosen, then in this standard, if this supporting construction is standard supporting construction is used, then the landing door can go into any type of supporting construction greater than 600 kg per meter cube of density material at site. Then a minimum of exposed area that is provided during the test. The minimum exposed area where the sample is installed should be at least 200 mm, and this supporting construction area should be subjected to fire. So if the landing door fails on supporting construction fixtures or anything, that is actually the compatibility issue between the supporting construction and the landing doors. So the material chosen to fix the supporting construction, to fix the landing door also, is supposed to be chosen wisely in that case. So before the test, we go through all the we'll take out all the material list that is being used in the construction of that particular landing door, and the drawings are to be submitted to the laboratory in charge, and they has to verify the complete details that is been presented in the drawing with respect to the installed sample. If there is any deviation, that is supposed to be edited, and the details, whatever is been missing, also has to go into the report and the drawing, where that will become the final report for this particular testing. So before the test, the gap measurements as per the standard should be taken. So if we find the gap measurements shown, the standard should be taken. That you can see in the presentation that G given, all those are this measurement that we are supposed to take once in the closed position of this particular landing door. Then prior to the test, the functionality test should be done on this landing door to open and close to at least a minimum width of 150 mm. So if it is possible, it has to be opened completely and closed before the test. And once it is closed, there is no adjustments or anything done on this particular sample, and it should be directly put into the testing. Then the second part is that the verification of gas flow measurements on before the test. So as I told, the EN 8158, the integrity measurement is not directly with gap gauges or cotton pad. It is based on the carbon dioxide leakage that is happening through the door from the furnace into the measuring system. So there is a canopy system given in the standard. Excuse me. If you see the standard, there is a particular canopy system that is being provided in the standard, and before the test, a verification of the flow measurement is done. And this constitutes a burner and a propane gas that is being used to burn the burner, and at least 50 minutes of verification process is done. First 10 minutes will be the preheating of the entire system, and 5 minutes will be the measuring time of flow systems. So you can see in the presentation, this is a videograph of the calibration thing done before the testing. So then during the measurement, we send the propane gas into the burner, and this is burned with the rate of 1.36 liters per second. And this, the standard says that produces a carbon dioxide of 0.25 meter cube per minute. So this carbon dioxide is sucked by a blower outside, and we measure how much percentage with respect to standard, and what we are getting comes into 10% of the measuring system. So we adjust the blower, and we make sure that this particular, the flue gas produced through this burning of propane gives 0.25 meter cube of gas through the system. And once we measure this, we make sure that the system is running correct. From there, the blower is set at that particular RPM to give a constant flow of that, and the test is being started. So you can see from the standard, this is the standard diagram that is being given to measure the entire setup. We have carbon dioxide sensors to measure the carbon dioxide from the furnace. We have carbon dioxide sensors to measure the carbon dioxide present inside the flue gas that is passing through. Then we have the differential pressure measurement system to measure the flow rate of gas flowing through this particular system. Then the blower to suck the to have the differential pressure between the canopy and the outside environment. Then we have other measuring systems, the barometer, thermocouple, all those things to have the correction factors for the flow measurements. Then the part 3 of this particular test is the instrumentation of the sample, in which we can split it into instrumentation of the furnace, and the second part is the instrumentation of the specimen. So instrumentation of the furnace, we have the differential pressure manometers kept to measure the differential pressure between the furnace and outside environment. So the standard says to keep minimum of 2 pascals, and it is completely a positive pressure test that has been done. Only then the flue gas inside the furnace can move out through the leakage of, if there is any leaking point in the door, only then the flue gas can pass from the furnace to outside and into our measuring system. We have the thermocouples to measure the temperature, time temperature curve. Then we have the carbon dioxide monitoring system inside the furnace, and also outside the system. Inside the furnace, we maintain the time temperature curve with respect to the standard. It is a cellulosic curve basically. So once the test is started, the furnace should run on the time temperature curve within the tolerance that is being prescribed in the standard. Then we have the pressure gradient that is kept inside the furnace. So as I told, this is a positive pressure test where the landing door is subjected to a positive pressure from the sill to the top of the specimen. So the pressure gradient should be 8.5 Pascal. And am I audible now? Hello?
Yes, you're audible, Akhil.
So there was a power loss, so I was just confirming it. So the pressure, differential pressure is maintained throughout the pressure gradient is maintained throughout the vertical gradient inside the furnace. Then we have instrumentation of the specimen, that is the canopy for gas collection as per the standard. Then we have the flow measurements as per the requirement that we have already set for during the calibration. The entire setting should be there when we start the testing. Then we have gas cooling and drying system to collect the carbon dioxide, where the carbon dioxide and the flue gas and the air sucked from outside is going to enter, and this is going to be very hot. So the sensors that is being used cannot accommodate into that temperature. So the cooling system and drying system should be there. Then we have gas flow measurement system to measure the gas flowing through the entire system. Then we have the carbon dioxide level monitoring station, where the carbon dioxide which is escaping from the furnace through the landing door into the measuring station, that is being measured and monitored. Then the sample deflection sensors, where the deflection of the particular sample is being recorded. Then we have unexposed site thermocouples in case of insulated specimens. Then we have heat flux sensors to measure the radiation that has been coming out through the landing door during the test. Then during the testing, when we start the test, after the calibration, we start the test, and we have the measuring systems on the place, and the criteria for integrity measurement would be 10 seconds of sustained flaming. If the flame is seen and it stays for 10 seconds at that particular location, then that makes an integrity failure on the specimen. Or a leakage rate of 3 meter cube per minute per meter after 40 minutes of the test, that will constitute an integrity failure. So there is a correction factor given the standard to which we will be comparing the pressure and the pressure of 20 Pascal, that is a standard pressure, and pressure inside the furnace with respect to the measured volume of the gas. And that from that the carbon dioxide leakage has been extracted, and the value is compared with the value that we have 3, with the value of 3 multiplied by the width of the specimen. So once it is exceeding the 3, the multiplication factor of width and the standard of 3 meter cube per minute per meter, then that makes the failure of the integrity. Then in case of measuring insulation, we keep the thermocouple unexposed site thermocouple on the specimen and measure the 140 and 180 and 360 degrees Celsius temperature that is been passing through the system into our thermocouple. Then that makes the insulation criteria satisfied. Then the heat flux is measured with a flux sensor kept 1 meter away from the specimen, and the radiation value shall be limited to 15 kilowatts per meter square during 1 hour duration or 2 hours, but the classification is only to 1 hour. And once the 15 kilowatts per meter square criteria is exceeded, that is the radiation performance of the particular specimen. Then the 5th part is the reporting, which is very important. Once we do all the testing and take out all the data, the reporting part is very important, where we have to give the details of leakage through the door during the entire course of the test, and time duration when the flaming has occurred, in case if it is occurred, then the deformation of the door, radiation emitted through the door, and unexposed phase temperature if it is measured, and what kind of classification this belongs to in that with respect to the data collected. And we, apart from this details in the reporting, we are also supposed to give the details that is provided in EN 1363 part 1 along with these details. That goes like the name, address of the sponsor, the date of the test, the reference numbers, what kind of product it is, and the manufacturer details of each product. So if a door is being tested with a particular material that is been bought from market or supplied from some other company, the company name with the complete details of that particular model or product that is being used in the landing door should be there in the report, and that has to be furnished data. Then what kind of supporting instruction is used for the testing, then the photographs and description of the specimen and what was the fixing mechanism that is being used during the test. All those data are supposed to be there as per the standard. Then we have a description of standard supporting instructions. So the thickness, the material used, the density, all those things goes into the report. Then the preconditioning, if there is anything, then the statement of laboratory involvement, if there is a selection, sample selection or anything like that, then that should be furnished inside in the report. Then the drawing, which is very mandatory to be included in the report, where it should have the complete detail of how the sample how the sample is, so that any clients who is using at the end user can easily know the same specimen that is being tested in the laboratory is being used in the site applications also. Then the ambient temperature, time temperature curves, furnace heating, the carbon dioxide data, all those and the results, everything is supposed to be there in the report. So this is the time temperature curve that will be provided after the test. Then we have the differential pressure measurement that has been taken during the test for the entire duration of the test. Then we have the heat flux sensor that has been kept, and we measure what is the flux data collected on the heat flux sensor, and that should be furnished in the report. So then we have the deflection. The deflection sensors are kept in the specific points that is being demonstrated in the standard, and the deflection data in graphical or in data form that is supposed to be going into the report. Then we have the leakage and the corrected leakage rate during the entire course of the test. So this will mark the integrity failure on any specimen that is used for testing. So for example, in the other case, when we are using a gap gauge or gap gauges or cotton pad to know the flue gas passage from the furnace from the furnace to the outside through the landing door. In this case, an indirect way is being used as the leakage of carbon dioxide from the furnace through the landing door to outside is being used as a data to find the integrity, how much opening is being happened in the system. If the opening is more, the more the carbon dioxide is going to come from the furnace to outside. So that is used as a value to measure what is happening into the system. So this is an indirect way of measurement in this case in EN 8158. So again, the field of direct application comes where the doors, if the door is being tested, any sizes less than the particular door that is being used for testing can be used at site. And also the width can be increased up to 30% of tested door. And after the extrapolation value, if the value is within the limit, then a 15% of increase in height can be used at site as an field of direct application. Then the point number A and B can be used together. And if the supporting instruction is used within specified range as per the standard, then any kind of supporting instruction, this particular material can be go into any type of supporting instruction. Or if there is any supporting instruction that is particularly used only for the landing door, then the landing door can go only into that kind of supporting instruction at site. So with this, I'm ending the brief presentation on EN 8158. Now, if there is any questions, I can take the questions. And thank you for listening.
Sure, I will start the question answer session now. David is asked, Mr. David Ball has asked a question that great detailed presentation will be at a point in the future. Examine similar subject matter as it pertains to escalators and general and specifically handrail products used in India. So Akhil, you can type the answer here. Or you can answer live as well.
We have at the point in the future. Examine similar subject matter. General so thank you for giving a feedback on presentation, and I hope the team will take up to arrange more presentation in this matter.
if anybody has more questions, can please feel free to ask any questions to Akhil. And Akhil will be really grateful to also answer the questions.
So what's it only mandatory to have 5 modes? So as per which code are you referring to? So the NBC has particular requirements on the testing on landing doors. So I have not gone through those requirements. If you can drop your email ID, I can look into it and share it for you. When leakages is suitable to test via air. So, Mr. Sheikh Wasim has asked, what about the pneumatic testing for any leakage? Is it suitable to test via air? So, are you referring to the leakage during the fire test, or are you referring to something else? So during the fire test, the leakage is measured only through this particular system, and the leakage is measured with a flow measurement system where we are setting up the blower into particular RPM where the flow is being first preset with respect to the calibration that we have before the testing. So we set what is the flow that is required. Then during the test, the air is also being collected. Carbon dioxide is collected along with the gases or few gases that is coming out from the furnace or from outside into the entire system. So this has a comparison with respect to the we measure how much is the carbon dioxide inside the furnace, then we measure how much is the carbon dioxide that is passing through the system, and we measure the flow what is there in the system to get previously set to attain the previous calibration. So there is a ratio between all those data, and we furnish a particular value that is then compared with the 3 meter cube per meter per minute requirement. So that's how it is been done. So is it? Yeah. So this is the only method as per the standard. So Mr. Prakash has asked, is the testing procedure common to all lift or only for fireman slips? No, any lift that is that requires the fire resistance is supposed to have this particular testing. It is not only to fireman's lift, but also to the normal lift that goes into the building above particular floor. And the landing door is supposed to be non-symmetrical. That is, the landing door is taking far only from the floor side, not from the other side. So the test is non-symmetrical test in this case. The door is non-symmetrical. Asymmetrical.
I think there are no more any questions. If anyone has any questions to be asked. Okay, Yunus has tabled. Yes, Akhil, you have more 2 questions.
Okay.
Akhil, there is a question
Yeah.
from Yunus, 15 field
David
of
Ball, other than carbon dioxide, what other toxins also measured in your test standard or test standard? So in this particular test, there are not toxic material is been measured. Only carbon dioxide is the requirement. So I don't think there will be so much toxic gas coming out from the furnace. If we are using LPG or some kind of combustible fuel, that gives out a majority part of carbon dioxide during combustion. So carbon dioxide is used to measure in this case. And a similar lift lining door assembly with a door opening or an opening width in the wall equal to one tested with yes. Yes. So when you do the landing door testing, if you have a particular size that is been tested, then the width of 30% can be increased at this site. So when the test is done at our facility, we put this into the report saying that this particular range can be covered, even though the tested specimen is 30% less than that. What could be the reason that the evacuation lift's purpose is being deleted in the draft? So I doesn't know the answer to that questions. I was not into the NBC.
So I think Mr. Prakash Kamath is asking what could be the reason that evacuation lift proposed is being deleted in draft of new NBC.
So I'm not into the NBC, so I doesn't know what was the reason behind that.
Okay, just allow some time. We'll try and answer. Kindly hold.
Yeah.
Mr. Prakash Kamath, we are sharing the response to your question. Please be hold, sir. And also, Akhil, Mr. Sheikh Wasim is asking how long does it take from sample submission to final report?
So in our laboratory, from sample submission to the final report, it takes 15 days. If the test is done like immediately after the submission of the sample, the time that is being used for schedule or anything should be taken out in this case.
Okay, if anyone has any questions to be go ahead or we can conclude the session. I think the questions are over right now. I would like to apologize for the technical glitch that we faced during the webinar. And thank you for all the audience who've been patient during the technical glitch which we faced. Also, thank you, Akhil. Thank you for taking your time, valuable time out. Jothi sir, I can understand that there are timings which we all are, busy into our weekday schedules every week. So I can imagine you taking out this valuable time for us. Thank you for that particular time. There is a reminder also that, we will be having these webinars every Tuesday starting today. So, we also can go ahead with the subjects, and definitely in coming future, we will be sharing all the information over the social media, as well as email and WhatsApp. So our second session, which is going to happen, that will be done by Bestomet, Mr. Sachin Jayachandran, who will be going ahead with the bringing EU standards to diverter police made in India, designed for the world. That is his subject for the day. Also, we are also having a third session, which will be on 30th of this month. So I will let you know the subject for that as well. Just please be hold.
And thank you for providing the platform for us to present.
You're welcome, Akhil. You're welcome. You're always welcome.
Yeah, thank you very much on behalf
Thank
of
you.
Aadit
Thank you,
Fire
Jothi,
Testing.
sir.
Thank you, Mr. Tak Matthews. The enthusiasm that you have is really infectious.
Yes, he is.
Yeah.
So third webinar topic will be safety with elegance, which is again fire-related glass doors with painted anti-drop sill hook fall protection. This will be done by Vitur. This will be on 30th of September. And as an audience, I just wanted to let you know that we will be hosting our IC quiz and IC symposium in Chennai this year, December. So, you know, we have already started registers, and the last date to register yourself for IC quiz is 20th September. So you may please go ahead and also register yourself for IC quiz. With that note, I take, you know, it is just a beginning for the IC platform journey. And I really look forward for your continued participation in the sessions ahead. You can contact me for any further assistance required. My number is 9082-731-535. And definitely people can get in touch with me if they are in touch with Akhil and Jothi sir, and others can contact me. Thank you. With this note, I will end the session for the day. Thank you very much.